This video will introduce the idea of inverse trig functions, and it will limit itself to degrees only because I think it's easier for all of us to think in degrees, and we're learning something new, so we're going to think in degrees and can switch to radians later. Okay, so here's a quick recap of the extended definition of sine and cosine. You think of a circle with a radius of 1 superimposed on the xy axis with its center at the origin. And then any angle you pick, with this being 0 degrees, right plus x direction is 0 degrees. This is the positive direction, that's the negative direction. Counterclockwise is positive. So any angle you pick creates a dot on that circle. That dot then instantly has coordinates x and y. Cosine of theta is defined as the x-coordinate of that dot, if the radius is 1. Sine is defined as the y-coordinate of that dot. And we can find those values precisely by using a really accurately drawn circle on graph paper on axes. And for example, let's say we wanted the sine and cosine of 160 degrees. We find the dot. We don't ever have to even draw the radius. Find the dot. The sine of 160 is the y-coordinate, so it'll be about 0.36. And the cosine of 160 is the x-coordinate, so it'll be about 0.95. And you can check that with a calculator, like a TI-84 or TI-89, and see how close you get. It's pretty impressive how close you can get using just this piece of paper to getting the right answers. Okay, now we do what I call going backward. Going forward was I tell you the angle, you tell me the sine and the cosine. Going backward is I tell you the value on the coordinate axes, you tell me what angle would have created it. So here's our example question. What angle has a sine of 1/2? Okay, another way of putting it that is the angle with a sine equal to 1/2 is what? Okay, well, we go backwards, and if you do enough of these forwards, then going backwards makes perfect sense. Okay, so think about going backwards here. So they said the sine is 1/2. Oh, sine. Okay, so that means y-coordinate. So I look at the y-axis and I find 0.5. Then I want to know what angle that comes from. And your inclination would be to go over here and say 30 degrees. But there's a second answer. You could also go this way and get 150 degrees. So those are both answers would be correct. So our only question is what angle has a sine of 1/2? The answer would be 30 degrees, also 150 degrees. But wait, you could have alternate, these are the two positions, only these two positions, that position in quadrant 1, that dot in quadrant 2. However, there are infinitely many ways to express these. We'll just look at the 30 degrees and look at the infinitely many ways to express it. I could go around once and 360 degrees and then 30 more. So the angle 390 degrees also has a sine of 1/2. Try it. Put it in your calculator, do sine of 390, and you'll get that. You could also go the wrong way, negative. That would be negative 330 degrees. Again, put that in your calculator, sine of negative 330. Make sure your calculator's in degrees. Go around like that, you will get 1/2. So there are infinitely many answers to that. We'll get back to that in a second. Likewise, we could ask B. What angle has a cosine of whatever we want? Let's see, what angle has a cosine of 0.3? Okay, there's 0.3. So we could read up to that angle, maybe about 84 degrees, or down to this angle. And we could express this angle as a negative, the way I do there, or a positive. Okay, so there are infinitely many ways to express it, but the method is the same idea. Okay, now we need a language to do this. So I don't, because no one in math wants to write the angle with the sine equals 1/2 is. So angle with sine of or equal to 1/2 is blank. Okay, all of this is written this way. You write the sine like you're normally writing a sine, then you put a -1 there, and you put 1/2 in parentheses. So this means the angle with a sine of 1/2. That's what this means. When you read that, you're supposed to think the angle with a sine of 1/2. How do you say is? In math, you say that, and then like that. This is what's called an inverse trig function, a going backward trig function. The angle with the sine of 1/2 is. Okay? There's an alternate way to write it, and you really need to know both because you'll see both of them. Arc sine of 1/2 is. Both are written. Now, one big warning here. That -1 there is not like 10 to the -1 equals 1 over 10. It's not an exponent. It's a horrible notation, but I understand where it comes from. But it comes from the general notation for inverse functions. But it's a very misleading notation for students because it looks so much like an exponent of -1. And what makes this even worse is if someone writes sine squared of of pi over 4, okay, that really is an exponent. Sine of pi over 4 squared. That's what it means. Same for any other exponent. Sine to the 10th. Yep. Okay. Anything. Pi over 4. Same thing. That's an exponent. But if you make that a -1, or in fact I think any negative number, it's not an exponent anymore. Not an exponent. It means inverse. Okay, so let's look at this notation and get a handle on it. See. When you see this, sine -1 of something, and I hate to use x or y here because we've been using x and y to mean the sine and cosine coordinates on the unit circle. So I don't use x and y here. I use the letter n. Inverse sine of a number. Okay, also could be written arc sine of n. Okay, equals. What this is saying is I am the angle. Inverse trig functions are angles. So this is an angle. I am the angle with sine equal to n. In other words, the sine of me is n. I am an angle and my sine is n. I am an angle and my sine is n. One way to think about this is you have numbers and angles. So for example, if I write the sine of 30 degrees equals 0.5. I call this, now I know they're both numbers, but just to keep straight, I call this the angle. 30 degrees is the angle, and 0.5 is the number. And that number will be between -1 and 1 because the limitation's on the range of sine. And there's the angle in degrees here. This whole video will be in degrees. Okay, so think of it that way. You take the sine of an angle and you get a number. This is the angle, we'll always call that theta in my videos, and this is the number, we'll always call that capital N in the videos. So you can write sine of, so we'll call this whole thing notation. You can write sine of theta equals n, or you can write inverse sine of n equals theta. Okay, theta for angles, n for numbers. Books and your teachers will probably use x's and y's here, and it's extremely confusing because you just spent all this time learning that x was the cosine and y was the sine. When their x and y are used in these, they mean something completely different. They have nothing to do with the axes on the unit circle. So to avoid that confusion with beginners, I only use theta and n here. So sine of theta equals n, sine of an angle equals a number, and inverse sine of a number equals an angle. That's an angle, like 30 degrees, which means this whole thing is an angle. And it takes a while for this to settle in, to sink into your brain. I remember it took me a while, but when you look at it, anytime you see an inverse trig function, you see that's an angle. The answer is going to be like 30 degrees, or 150 degrees, or pi over 4, however you're expressing the angles. That whole thing is an angle. The thing inside will be a number, like a number between -1 and 1. So that it'd be inverse sine of like 0.6. That kind of thing. So the number's in there, the number's the argument in there, and the whole thing as a whole is the angle. Okay, the last thing to know about inverse trig functions is what are called their range restrictions. And we'll only do this for sine and cosine right now. Or I guess I should mention them all. And this is why you absolutely have to learn the unit circle and the extended definition of sine and cosine before you can do inverse trig functions, because it's because of their range restrictions. Okay, consider this. Inverse sine of a number equals theta. Remember how before we found there were infinitely many answers. So the inverse sine of 1/2. Inverse sine of 1/2 was 30 degrees or 150 degrees or 390 or -330. Infinitely many answers. So to make this simpler to use and to create a true function, mathematicians artificially restrict the range. So we're going to draw our unit circle and think, okay, we're talking about inverse sine. We're talking about figuring out the sine, so that means we're on the y-axis. And now think, if you had a value up here, if you wanted the inverse sine of 0.5, you would go here, and you could read over here to 30 degrees, or over here to 150 degrees, which would be easier, of course, reading over to 30 degrees. So they don't use this part, they use this part. They're restricted, so there's only one answer. So your calculator, for example, is programmed. If the number that goes in here is from 0 to 1, it will give answers from 0 to 90 degrees. Okay, but what about down here? Okay, we could go left or we could go right. We kind of naturally go right. Further, that creates a continuous function with that over there. But if we call this 270 to 360, we get this jump. 270, 350, 359, 359.99, and then suddenly we jump to 0. 359.9999, and that's not a continuous function. So these are defined as negative. Negative 10, negative 20 degrees, and so forth down to negative 90 degrees. So the range on this, the angles that are allowed, are artificially restricted. We'll put it this way, inverse sine of n. Remember, inverse trig functions are angles. That angle is artificially restricted to be between negative 90 degrees and 90 degrees. You can try this on your calculator. Put in the inverse sine of negative 0.5. Inverse sine of negative 0.5, and you will get negative 30 degrees. So it's restricted artificially to that. Same for cosecant. Inverse. Inverse cosecant. Cosecant is the reciprocal of sine, so it's in the inverse sine family. And inverse tangent. Also restricted to these angles. I like to say that, well, this is like a mask. If you think of this as a person facing to the right, wears a mask. Okay, for cosine, you get something a little different, but you have the same issue. You have to restrict the range, but the result is a little different. Okay, here's cosine. Here's the unit circle, and cosine has to do with the x-axis, so that means our number, our n, is going to be on this axis. Okay, and imagine you wanted the inverse cosine of 1/2. Okay, in other words, remember, inverse trig functions are angles. What's the angle that has a cosine of 1/2? So you look on the x-axis for 1/2, then you can go up here or down here. Which would you rather do? Of course, everyone's going to want to go up. Okay, so we use that part, we use quadrant 1. Then imagine over here, inverse cosine of negative 1/2. Would you rather go down or up? Well, still people are going to want to go up. And so you wind up with this. Okay, and that covers the entire, all the values of the domain here from 1 down to negative 1. We go up top. This actually creates something that's a little easier to digest, going from 0 to 180 degrees. So inverse cosine is restricted. Your calculator is programmed. It will only give an answer between 0 and 180 degrees inclusive. It won't give any of these answers down here because scientists want to limit this as a function where you put in a number, you only get one number out. So it's a true function. Likewise for inverse secant and inverse cotangent. The last one is defined differently in different books. It's restricted differently in different books, but this is the most common definition, and it's the one that the advanced placement test uses, so that's what I'm going to put. So I like to say that the inverse cosine family wears a hat, and the inverse sine family wears a face mask. It's like it's fencing, and it's pointing that way, and it's wearing one of those fencing masks, if that helps you remember the shape. So that's the reason, that's the range restrictions.